Hey everyone, Michael Unger here at the MacMillan Space Centre in our Ground Station Canada Theatre, located on the unceded territory of the Musqueam, Squamish, and the Tsleil-Waututh, here with another edition of Ask an Astronomer, our first Ask an Astronomer with our new astronomer, and that is Marley. Hey Marley, how's it going?
It's going good. How are you, Michael?
Not bad. How was the trip over? You were in Calgary and now you're over here on the West Coast?
I am. It was a good trip, a bit of a bumpy landing with a coyote on the runway, but it was avoided and everything was okay in the end.
Wait, hold on. A coyote on the runway. What
Yes.
exactly happened here?
As we were about to land, the pilot made an erupt, brought us back into the air really abruptly, and came on the intercom and said a coyote had run into the runway at the last second, right where we were supposed to touch down. So we had to do a little loop and a second approach, but I ended up making it here okay. And so did the coyote. It was fine.
Okay, well, that's good. A happy ending for all. Glad that you're here safe. Glad that we're going to be able to get started on a whole new year of Asking Astronomers. And you prepared a bunch of really cool stories for us. So, speaking of flying, we've got another update from our favorite helicopter on Mars, Ingenuity. I'm not sure if there's been any coyotes that Ingenuity has run across on Mars, but we've got a big update on Ingenuity, plus also some really cool information on stellar flares, which I had to learn about, which are closely related to solar flares, but of course, these are flares coming from other stars. So lots of really cool information. Thank you so much for everyone joining us here in YouTube. Of course, just like always, put your questions into the chat on YouTube and we'll get to all of them. And of course, if you have any questions about anything under the universe for the next half an hour, we are here. But let's get to our first couple big stories. Take it away, Marley.
Yeah, so I wanted to start off with the big Ingenuity update. So on April 30th, Ingenuity had a successful fourth flight, reaching an altitude of 5 meters and flying 226-meter round trip, and was in the air for 117 seconds. And so another announcement that came out of that was, due to Ingenuity working so well and exceeding expectations, they're actually moving it into a new operations demonstration phase. So our fourth flight and fifth flight for Ingenuity will be in a transitional phase as it preps into this new operations demonstration. And the sixth flight will mark the beginning of that. And NASA just released that, what the details of the fifth flight right before this broadcast. So it's scheduled for tomorrow, Friday, May 7th, with a total flight time of about 110 seconds. So this is kind of what they hope to happen. It should take off at 12:26 Pacific time, climb to 5 meters, and then head south 129 meters. But what is different about this flight and why it's in a transition stage is that Ingenuity will not be returning to the Wright brothers airstrip where it's been landing thus far. It's actually going to climb to 10 meters once it does its heading south, take images of that area, and then land there. So it will have a new landing site at about 12:28 Pacific time, and all the data should be retrieved by 4:31 Pacific time.
So this is literally up to the minute information. This is really cool. Everyone that's watching this, you are getting the most information, up to the date information on Ingenuity. And you just said the Wright brothers landing strip. Is this the actual name for the area that Ingenuity has been landing and taking off on?
Yeah, they've been calling it the Wright brothers airfield, I think is what the name is. But because they a little homage to the Wright brothers, who were one of the first to do flight on Earth.
Okay, so this is really fun. We'll be looking forward to tomorrow, and people can maybe follow along on NASA's website. Is that correct?
Yeah, NASA should be posting updates. They have a really great blog page specifically for Ingenuity, where where I found all the information when they finally released it. So that's a good place to go for sure.
Awesome.
And
So it looks like, on schedule and pretty much everything going as planned with Ingenuity. I know
yeah,
there
so
was some
far.
hiccups recently.
It did have a little bit of a glitch on the attempt of the fourth flight, so its date got moved, but I think they fixed it. So providing everything goes well and no crazy weather, it should be good to go tomorrow.
Awesome. Amazing. So is that all we have for Mars? Should we transition off to beyond our solar system?
I have a little bit more on Mars because of
Okay.
this new phase I wanted to talk about. So Ingenuity is performing really, really well. And it's very exciting because its first phase was to see if flight was even possible. And it is possible, and we've done a really good job at it. And so now, because it's exceeded expectations and because Perseverance is ahead of schedule, and because Perseverance science team has chosen a new nearby location of rocks and craters to look at, they have decided to pair up Ingenuity and Perseverance in kind of a joint phase. So Ingenuity will be working alongside Perseverance, traveling alongside the rover. And this may look like flying to wherever Perseverance drives to, provide us a short distance, or flying and trying to scout new potential rover routes and landing at the future parking spot for Perseverance. But this will also mean less frequent flights. So they don't want to interfere with Perseverance's science mission, because this working with Ingenuity is just a bonus. It's not Perseverance's main mission. And so that still takes priority. So they'll be less frequent, moving to every 2 to 3 weeks instead of every couple of days that they were hoping for. And we are going to get a lot more pictures as it increases its use of aerial observation for science targets and provincial rover routes, as well as helping to map elevation.
And that's really what we want. We want the cool pictures,
Always,
right? Like,
yeah.
Awesome. Well, I was super excited. Anything more on Ingenuity?
No, that's it. I hope it has a successful flight tomorrow. I'm really looking forward to this new operations mission it's got.
Excellent. Okay. Well, so I teased out at the beginning, we're talking about stellar flares. This was sort of brand new to me. I knew that, of course, that all stars are kind of like our sun, and our sun gives off these flares. We actually have seen some even from our scope when we do some daytime solar viewing like we are today. You know, you can come down, you can actually see flares coming off our sun, but this also has elsewhere in our galaxy, and we sort of categorize them in this stellar flare category. And you've got some information about them.
Yeah, so recently there was a stellar flare out of Proxima Centauri. So Proxima Centauri is a red dwarf star that's 4 and a bit light years from Earth, and it's only an eighth of the mass of the sun. So it's a lot smaller and a lot dimmer. But it does have a planet in its habitable zone, Proxima Centauri b. And so, quick background on stellar flares: they are bursts of radiation due to the magnetic fields in a star. And so we see them as bright flashes. So this picture here is a solar flare on our sun. Stellar flare, solar flare, difference is one happens on our sun and the other one happens on stars. So we see them as bright flashes, but Proxima Centauri's was particularly interesting because it peaked in the ultraviolet and the radio. We tend to see our solar flares more in the X-ray and optical. So this is an artist's image of what this flare may have looked like from Proxima Centauri. It was incredibly large and incredibly bright. They were looking at data they collected in 2019 using 9 different telescopes, both ground-based and in orbit, in order to track across the electromagnetic spectrum, because we don't really know if these stars have flares or how they look or where all their energy comes from. So by looking at the star for over 40 hours over a period of several months in 2019, they saw an incredibly large flare on May 1st, 2019. It only lasted for 7 seconds, but the star itself went from normal brightness to 14,000 times brighter when viewed in the ultraviolet wavelength.
Okay, so even just like looking at this artist rendition, so we sort of do have to take that with a grain of salt. This isn't an actual photograph, but they were using the actual data. So does this mean that this particular flare, was it a particularly large flare? Like we don't see the like it didn't last that long, but you said that it was particularly bright, and the flares that we see on our sun, they don't get that bright that we have observed, right?
No, this one was much, much larger than the flares we've seen on our sun, which scientists are particularly interested in because the star is so much smaller than our sun.
Okay.
So it's a big problem because we're really interested in exoplanets. And so Proxima Centauri is a system very, very close to ours, and we can look at it and observe it well. And it has an exoplanet in its habitable zone. But if these flares happen a lot and they're just as powerful, it can actually strip away the atmosphere on that exoplanet, leaving it uninhabitable for life as we know it.
So what you're saying is that this isn't good news for some of those exoplanets that are orbiting around Proxima Centauri.
No, it's really, really bad news. And in fact, a lot of the exoplanets we study are orbiting stars that are similar to Proxima Centauri. So all this knowledge will help us figure out more about the possibility of life on those exoplanets.
Yeah. And those particular exoplanets, I think, were, of some interest because, of course, it would take a very long time to send a spacecraft. But relative to some of the other exoplanets that we have discovered, realistically, we could probably send one, even if it was that the Starshot one that was going almost at light speed, it would potentially get there within someone's lifetime. But what you're saying is that, these planets, especially the ones in this solar system, probably don't have life on them.
Probably not. Yeah, it'd probably be, and if it is life, they would have to deal with a pretty brutal environment from these flares for sure.
Okay, really interesting. So tell us more. You've got some more information about sort of like stellar flares around our galaxy.
Yeah, so they've also out of the university in Austria may have come up with a new technique to spot CMEs. So a CME is a coronal mass ejection, and this picture here is a coronal mass ejection from our sun. So what it is, it's a burst of charged particles and plasma that comes out of the star. So, and they're located in the corona, which is like the outer atmosphere of the star. That white wispy bit that you see on our sun during a solar eclipse, that's the corona. And so that is where all this material bursts out of. But it's hard to observe CMEs in our own sun because it's hidden by the brightness of the star. So the sun is very, very bright and blocks out the corona, why we can only see them during a total solar eclipse. And so it's even harder to see them in stars outside of our solar system. So this new technique that they've come up with is that the team looked at historical data from 3 different telescopes, and they looked at over 200 stars, and they found 13 stars to possibly have CMEs. And so they looked at it by looking for dips in the energy that the star was putting out. So a CME, because it's a burst of plasma and material and radiation, the overall energy the star is outputting will do a little dip in certain wavelengths. So they looked at these wavelengths and tried to find dips that would correspond to a CME, and they found some. They found 13 stars with 21 events total, but more research is definitely needed to check and to make sure that this could actually be something used to spot CMEs in the future.
Okay. So just to bring this back, to Earth, we're observing these really cool and really dynamic events happening on these stars. But like you said, CMEs are, sort of common on our sun and certainly ones that we need to be aware of. So what are some of the things that could happen, to our planet or even like to us specifically if these CMEs are particularly powerful enough to reach Earth?
So recently a CME did actually hit Mars and everything was okay. The scientists had time to prepare, but there have been times when a CME has hit Earth in the past. And I think the late 1800s, a CME hit Earth, and it actually took out all of the telegraph systems in Northern America and Europe at the time. And they estimate that if that were to happen today, we had a near miss recently in July 2012. There was a near miss of a CME. It missed us by 9 days. And had it hit, experts estimate that it would have taken us between 4 years to a decade to recover economically from that, because they have the power to wipe out our electrical grid and anything hooked up to any sort of electricity at all. When one hit in 1989 in Quebec, it brought down the entire Quebec power grid.
Oh, wow. So let alone pandemics, little viruses to take us down. The sun could potentially do this as well. Is there anything that we can do? Astronomers are, trying to predict them a little bit more so that we can get a little bit more of a warning. But so let's say that, we do see one happen. Like, it's not like we can just like turn on the Earth motor and get out of the way, right? Like, what could we potentially do?
The best we can do is prepare for them. So there is good news. CMEs on our sun tend to happen when the sun is particularly active. And the sun goes through an 11-year cycle of activity and non-activity. So we can prepare for them that way by trying to monitor where in its cycle the sun is, and also looking at features on the sun like sunspots and such, because CMEs tend to appear over sunspots. And as a result of that, NASA actually has a whole bunch of probes out looking at the sun and studying the sun. It's called the Heliophysics Observatory. And it's a collection of different spacecraft with joint partners from across the world that specifically are meant to monitor the sun and better understand the events that happen on it, like CMEs.
Awesome. So, of course, if you want to go and actually observe, some of these sunspots that Marley just talked about, you can come down to our telescope on Thursdays. Today, on clear days, we are using our telescope to look at the sun. So Thursdays are your day to do that. Friday evenings, if you want to look at, of course, the planets and the stars and the moon in the evening sky. On solstice, though, June 20th, which is a Sunday this year, we are also going to be opening up our observatory for solar viewing. We're making some sundials, so doing some fun activities. So circle June 20th and come celebrate solstice and have a look at the sun with us. So if you have any questions about solar flares, CMEs, want to get in on what Ingenuity is doing on Mars, you can put your questions into the chat of YouTube. Pride is really wondering about, life may not have arisen on land, just as it didn't really arise here on this planet. So is there potential that life could be hidden underground, perhaps sheltered from some of these CMEs on these worlds, like the one orbiting around Proxima Centauri?
It is possible, I would think, but I think a bigger concern would be the potential of the atmosphere being stripped away, because that is what protects us from the sun's harmful rays. And so if a planet doesn't have that, a lot of the ionizing radiation could still get in and penetrate things underground.
Okay. So let's transition now, because there were some other news that we could get to. And of course, if anyone out there has any questions about anything in the universe, any things that you're learning about, any things that you have read about that you could potentially have questions about, maybe it's pertaining to what we learned about on Tuesday. We had some really cool talks all on the Star Wars universe. May the 4th be with you. Marley had a really great talk looking at some exoplanets that could be compared to worlds in the Star Wars universe. Perhaps you have some questions about that. Our next Cosmic Night actually is going to be on June 16th, and that is going to be all on dinosaurs and the asteroid or comet. I have heard a lot of people call it the comet, but we have a really great speaker from Harvard that's going to be joining us that has done some research on that particular event that wiped out the dinosaurs. So come and join us. You can find tickets. I don't think they're up on our website yet, but definitely check that out on our website. And that is the next Cosmic Night in June. So Marley, there was another space story that happened recently that was near and dear to my heart, one that people interact with actually in our gallery space, and that was the death of the Apollo astronaut Michael Collins.
Yeah, I was really, really sad to hear. He was a very interesting man who, one of the first, never set foot on the moon. And I hate that they describe him as the forgotten astronaut, because he's not forgotten. I remember him very fondly. Never knew him, but the fact that he was in the lander and everyone else got to go on. And that one photo he took of him just by himself, he took of the lander as it was descending onto the moon with the Earth in the background and everyone in the world in that photo except for Michael Collins. That's one of my favorite photographs from that Apollo mission.
Yeah, absolutely. That's a great one. It's fun. It's funny to think about that particular photo is not necessarily attributed to Michael Collins. It's just it's more actually associated with Neil and Buzz, because they were the ones that were on that on the Eagle lander. But of course, somebody had to take it, and somebody also had to fly the spaceship, to the moon and back. I like to think of Michael Collins as like Space Dad. He's waiting in the car, while the kids went out and played on the moon and then had to like get them back to Earth safely. So he was really, very super integral to that mission. Certainly didn't get the accolades that Neil and Buzz did, but super inspirational. And like I said, in our gallery space, we have his training suit that he used to train on the Apollo mission. So next time that you come and visit us, you should definitely check that out.
Definitely. And I don't know, he was just as brave, just as courageous as the two who walked on it. So he'll be missed, I think, a lot.
All right, so we've got another 10 minutes, Marley. Is there anything coming up that you're looking forward to? We've got a bunch of asking astronomers, throughout this year. What are some of the big stories that they're going to be keeping your eye on for the next little while?
I'm definitely going to be keeping my eye on the Ingenuity rotorcraft. I love that little thing, and I'm really, really excited for its, hopeful flight tomorrow and to keep itself in the air and keep on going. I'm going to keep an eye on Perseverance as well. I know that there was a discussion between the Ingenuity team and the Dragonfly team, which is the hopeful mission to land on Titan. I want to go back and watch that conversation because a lot of what Ingenuity is doing will be essential to Dragonfly's flight.
Yeah, so let's talk about that because one of the main things that they're really testing is how Ingenuity can fly on a world like Mars that has a very thin atmosphere. So Dragonfly also wants to do the same thing. So how would you compare the atmosphere of Titan to the atmosphere of Mars?
It's pretty different. It's made up of different elements and different materials as well. The big thing that they're concerned about is powering the Dragonfly because Ingenuity is solar powered. It has its little panels on top, but the atmosphere on Titan is too thick for the light from the sun to penetrate through because it's so far away. So it'll be run differently, more similar to how Perseverance is being run with sort of a battery. And so a lot of what the team is wondering is how can they still do autonomous flight while managing that battery and the weight and everything they have to consider with that. And Ingenuity's helped a lot in terms of how fast the blades have to run, the different technologies used to do that. And I think there's a lot of crosstalk between those two teams.
Yeah, I can imagine the logistics of, just trying to communicate. I know that they have done this before, with missions like Cassini and Juno that are orbiting, those gas giant planets. But we're talking about something that's a little bit more precise, trying to communicate with a helicopter flying on such a tiny world so far away from Earth must be a challenge.
No, it definitely will be a challenge, a very big challenge, but especially because Ingenuity, its entire body is maybe the size of a tissue box, right? But Dragonfly will be the size of a small car, so it's going to be a lot larger, and so they won't be able to test it here on Earth at all. They're going to have to rely a lot on models and things like that to see if what they've done will work. And so it'll be similar in that the first real test flight won't happen until it's on the planet, but they can test even less due to the size of it.
Oh wow, so cool. And again, so that's things that you're going to be looking at. But Marley, very soon you're going to be able to play around in our planetarium and get to interact with the public in person. So what are the things that you have sort of like taken from like your schooling? What are sort of like the things that have really captured your attention? You talked a little bit about it the first time we met you, but what are the things like in the universe that really draw you to learning and teaching about space?
I'm very, very interested in galaxies and their lives because we talk about a lot about stellar lives and how stars live and die. We don't hear so much about galaxies. They're a lot bigger and they're made up of a lot more things than just one star. So I'm interested in how they live and they die, particularly how active they can be with black holes and jets and things like that. So I'm always interested in that. But I always have loved talking about space to people of all audiences. I always had a ton of questions when I was a kid about space because it's always there and it's something you can always look up and wonder about. And so it's always good to be able to answer people's questions now.
Yeah, so it's interesting that when you describe galaxies, you're almost describing them as if they are one entity, even though inside of them there are billions of stars inside of them. So when you say that you're studying sort of like galaxies as a whole, like what sort of features are you looking at specifically when you're talking about the galaxy as a whole?
As a whole, I did a research project at the University of Toronto, actually studying what they call active galactic nuclei, which is just like the inner center, kind of the core of the galaxy that's particularly active. So a supermassive black hole in the middle, but or something like that. And so a lot of those galaxies like accrete matter into this black hole, and it's just weirdly luminous and weirdly active compared to other galaxies. And they don't know why that happens, or if that happens at a certain stage in a galaxy's life or things like that. And so it's interesting to see where that leads and the questions that come from that, but also because at some point you would think, okay, the sun will die, the stars around us will die, they'll explode or do what they do. So will a galaxy, quote unquote, go out? Like, will there be no more lights left in a galaxy despite all of those stars in it? So those are kind of the questions I find myself asking a lot in relation to galaxies.
Weirdly luminous. I like that could sound like maybe a paper that you could write about galaxies.
Yeah, weirdly luminous. It's just, yes, they're very interesting. I like them a lot. Ask me questions about it anytime.
And how does that relate to dark matter? I know that we've talked about dark matter. We had a event here last year in October around dark matter, because of course, when you study the speeds and how galaxies are rotating, that's really that's really kind of like the focus of our dark matter research, is on sort of like the galaxies as a whole and the rate that they're spinning at.
Yeah, it could function into dark matter a lot, especially if you consider those accretion disks that I mentioned, where matter is going into the black hole and being pulled over the event horizon. It could have something to do with dark matter. It might not. Dark matter is tricky. Its name comes from the fact that, according to the mathematical equations, there should be something there, but we can't see it. So it's dark matter based on the math. And so it's always very tricky to consider and figure out. And people have devoted their lives to it. And I'm in awe of them, because I think I just get way too impatient to do all that work.
So you're very impatient. So you're more of you want to make direct observations and make your calculations right away. Is that the kind of astronomer you are?
Yeah, I want to see it, and then I want to, work with the data. I don't want to have to wait very long, which is, difficult when you're looking at things so far away.
Exactly, because you're looking at information that has come from in some cases hundreds of light years away.
Yeah. Oh, yeah. And it's very annoying. And the time scales are so long too. So patience is a virtue here, and I need to work on it.
All right. Well, over the course of the next year, glad to have you on board, Marley. This is going to be really fun. Of course, every second Thursday here at 2 p.m., except because July 1st falls on a second Thursday. So we're going to have a special Ask an Astronomer on June 30th. Do you know what the special day June 30th is, Marley?
That's asteroid day, isn't it? Or it's that week, right? Yeah.
Yeah, asteroid day. So we're going to focus all on asteroids. Of course, that's going to be a big focus for June as well, including that cosmic night. So make sure to check our website for all of those updates, and make sure to check here on YouTube every second Thursday at 2 p.m. Pacific time. Thank you all so much for joining us. I'll see you next time.
Bye, everyone. Thanks.